Hello, my name is Melania Cabezas, and I'm going to present the work that I carried out with my colleague at the University of Granada, Pilar León, and which deals with multiword-term bracketing and representation in terminological knowledge bases. We also want to thank the organizers of eLex for allowing us to share our work. Thank you. Well, multiword terms are very frequent in specialized language. They are structurally and semantically complex for different reasons, and unfortunately, they are not usually accurately described in terminological knowledge bases, in TKBs. In knowledge-based resources, an accurate description would entail making bracketing or structural disambiguation explicit. For example, in the multiword term, reactive power consumption, reactive power modifies consumption, and this facilitates the identification of adequate interlinguistic equivalents. For example, consumo de potencia reactiva in Spanish. However, an inadequate bracketing complicates translation. So the inclusion of multiword terms in knowledge-based resources can benefit from this structural disambiguation, which can assist both terminologists, which seek for equivalence, and also final users, because the representation of multiword terms can be enhanced by placing them in relation to other concepts entries based on their dependencies. For example, reactive power consumption could be related to its hypernym consumption, and this would facilitate knowledge acquisition. Our aims were to develop a bracketing protocol based on bracketing rules and corpus querying. For this purpose, we use bracketing models available in the literature, such as the adjacency, dependency models, and also surface patterns, among others. We also used a baseline of 103 multiword terms, which were manually bracketed. 2 corpora were also used. One was the wind power corpus of 3 million words, and the other one was the GOAG corpus, which is composed of 2 billion words. 34 corpus queries were designed based on bracketing models, and these were used through the Sketch Engines API. We also developed 16 bracketing rules and finally evaluated the protocol. And our ultimate goal was to produce an enhanced description of multiword terms in TKBs. As for the bracketing models that are already available in the literature, one of them is the adjacency model. All of these models try to distinguish among the head of the multiword terms and modifiers, for example. This adjacency model tries to evaluate whether offshore wind, in the multiword term offshore wind turbine, or wind turbine are the most frequent combinations. We perform these queries by means of SQL queries in Sketch Engine, and we develop a rule that summarizes this behavior. As for the dependency model, it evaluates whether the most frequent combination is offshore turbine or offshore wind. And again, we developed a rule that sums up this behavior. The shortening model analyzes whether offshore wind, offshore turbine, or wind turbine are the most frequent combinations, and then all of these models establish the preferred bracketing. We also search for insertions. For example, in offshore wind farm, we established that offshore was the modifier of wind farm because we found offshore shrouded wind farm. That is, other terms can be inserted between the 2 parts of the multiword term. The formation of other multi-word terms is also indicative of bracketing. For example, in offshore wind farm, offshore modifies wind farm because we can also find onshore wind farm. So in this case, we perform 6 queries. Here we have also the SQL example and the rule that was developed. We also search for surface patterns that are, for example, hyphens, as in the case of grid connection cost, in which grid connection modifies cost because we found a hyphen between grid and connection, which links these two parts. Other surface patterns are the possessive genitive, the presence of concatenation or monolexical compounds, inflections, changes in word order, the presence of acronyms too, as in permanent magnet generator. Permanent magnet has an acronym which is PM, and this indicates the link between these two parts, permanent and magnet. And also brackets, the use of prepositional paraphrases such as generation of wind power, which points to the bracketing in wind power, which modifies generation. And also verbal paraphrases such as wind turbine installed, located, situated, offshore. Okay. And now we are going to talk about the rules performance when the protocol was evaluated. Well, in this figure, we can see the performance of each of the rules considering the balance between frequency and reliability. And we found that the most useful rules were adjacency, the formation of longer multi-word terms, dependency, and shortening too. We found that corpus size and type have an influence on the results. In particular, the wind power corpus, even though it was smaller in size, it provided better bracketing results for the multi-word terms dataset because it belongs to the wind power domain, and the multi-word terms belonged to the wind power domain. And therefore, domain specificity can be considered a factor for the performance of the protocol over size. The DOAG corpus provided better results for certain indicators, which were related to the surface patterns that were considered in the previous slide. For example, hyphens, concatenation, inflection, abbreviations, these were more frequent in the DOAG corpus. And if we look at the figures without taking into account when no results were retrieved, we find that most of the rules were more reliable in the wind power corpus, which highlights again that domain specificity is relevant to the performance of the protocol. Regarding the overall evaluation of the protocol, we analyze the output based on the following aspects. First, we analyze whether the resulting bracketing agreed with the baseline. Second, we observed whether the candidate bracketing was the same in both corpora. And third, we evaluated the confidence of each bracketing based on the number of rules pointing in the same direction without considering when no results were obtained. In half the cases, the rules showed 100% confidence, from which about 96% for the wind power corpus and 95% for the DOAG corpus agreed with the baseline. However, this figure shows that in both corpora, the bracketing failed for the following 13 multi-word terms. And we selected them to perform a more in-depth analysis of the possible causes. We also observed that the fact that more erroneous bracketings were found through the DOAG corpus might indicate that, again, domain specificity is what matters the most. And so the results of these 13 multi-word terms were analyzed based on the following possible causes. First, the nature of the multi-word terms, for example, their left or right bracketing, the possible omission of constituents, their syntactic structure, and so on. We also observed the formulation of the corpus queries, searching for possible mistakes, and we analyzed the rules confidence level. And finally, the fact that some rules might be noisier than helpful and could that bias the results. As for the possible causes of these failures in the protocol, we found that there was a bracketing difficulty in multi-word terms formed by an adjective, a noun, and a noun. And this calls for the replication of the study with a more balanced dataset in terms of syntactic structure. Regarding the left or right bracketing, we found no apparent influence on the success of the protocol. But, well, in fact, we found no apparent influence because the set of failed multi-word terms was quite balanced. Furthermore, multi-word terms whose head was plant or level, and those multi-word terms whose modifiers were offshore wind, usually provided a variable bracketing as a result of multidimensionality. And this results in bracketing errors or in different possible bracketings. For example, offshore wind power can have two bracketing structures. The first is offshore as a modifier of wind power, because this can be understood as wind power that is produced offshore. And also the bracketing can be offshore wind modifies power, because we can understand that power is produced from the wind that is present offshore. Additionally, we found no errors in the formulation of the corpus queries, and we didn't find rules that were more misleading than helpful in our multi-word terms. And in conclusion, we observed that the protocol delivers promising results that can be helpful in terminology management scenarios needing a thorough description of multi-word terms. But obviously, this study should be pursued in the future to retrieve more complete results and different results in other sets of multi-word terms. And as we said before, our ultimate goal was the representation of multi-word terms in TKBs using the information provided by bracketing. And so we developed a specific multi-word term section in the terminological knowledge base ecolexicon, which is devoted to environmental science. This is a general view, the summary view of this new multi-word term section that has been designed. And this view summarizes all the information that is included in this section. For example, if the user introduces the term turbine, he or she can see different information. First, the multi-word terms that are formed from this term, turbine. For example, downwind turbine, offshore turbine, turbine blade, wind turbine design. That is to say, turbine can be the head or the modifier of the multi-word terms. Users can also have access to the equivalents for the time being in English and Spanish. For example, downwind turbine, aerogeneradora sotavento. Morphosyntactic combinations are also available. These morphosyntactic combinations focus on part of speech annotation, the wind turbine, adjective, and noun. We can also see here the bracketing structure. And finally, semantic combinations are provided, which show the bracketing structure and also the semantic categories, roles, and relations present in the multi-word terms. And if we have access to every particular tab, we can see more specific information. For example, in the multi-word term formation tab, if we introduce the term generator, we can see the different multi-word terms that are formed from this term. For example, squirrel cage induction generator, bound rotor induction generator, as well as their term variants, their definitions, and additional options that can be accessed by clicking on the right button. And here, for example, we can find the bracketing structure of the multi-word terms. It should be noted also that multi-word terms are organized according to the dimension emphasized by the multi-word terms. For example, the terms that are described here describe different types of rotors of the generator. Okay. The equivalence tab shows the multi-word terms formed from generator to, for example, and their equivalents in Spanish. And we also have access to additional options and to the bracketing among these additional options. The morphosyntactic combinations tab shows a specific combination of parts of speech, for example, adjective and common noun and turbine. And we can see commercial wind turbine, conventional wind turbine, large wind turbine, as well as the parts of speech of the words and their bracketings. And one specific function is the comparison of morphosyntactic patterns in English and Spanish, which can be relevant to compare the patterns that usually differ in both languages. The semantic combinations tabs is similar to the previous one, but focuses on semantic information. For example, here we have a search for the category magnitude and change. And we have the following multi-word terms that present this pattern: voltage control, voltage dip, voltage drop, voltage fluctuation. We can see the semantic categories of every constituent, the semantic role, and the semantic relation between the parts. And we can also compare the semantic patterns in the multi-word term in English and their equivalents in Spanish, because there are usually differences. And also we observe the bracketings. And to conclude, we have observed that the most productive bracketing rules were the adjacency, the formation of longer multi-word terms, dependency, shortening, and paraphrases. However, it is advisable to perform queries in domain-specific corpora and not necessarily in large corpora. These large corpora are more useful for surface patterns such as hyphenation, concatenation, and so on. And we found that a systematic approach to bracketing can benefit from the design, can benefit and can be useful for the design of multi-word term entries, as we have presented. Future lines of research. We plan to use a new dataset with a balanced set of multi-word terms in terms of syntactic structure and also right and left bracketing. And we also plan to evaluate term entry design among users. And that's all. Thank you very much for your attention.